Hi class, let's have more examples regarding logarithmic functions, but this time, let's have these following examples to illustrate the graphs of transformation of a logarithmic function. Now, let's have this example. So, what we're going to do is just sketch the graph of y is equal to 2 logarithm of x base 2. So, determine na rin po natin yung domain, range, vertical asymptote, x-intercept, and 0 of the graph. So, first, let's complete our table of values. So, this is just easy because for us to compute or to get the y coordinates of y is equal to 2 logarithm of x base 2, all we need to do is multiply the values that we have for logarithm of x base 2 with 2. So with that, let's solve for the y coordinates of our second function. So we have negative 4 times 2, we have negative 8, negative 3 times 2, negative 6, negative 2 times 2, negative 4, negative 1 times 2, negative 2, 0 times 2, 0, 1 times 2, 2, 2 times 2, 4, and last, 3 times 2, 6. So, ayan, nakumpleto na po natin yung ating mga y coordinates for our y is equal to 2 logarithm of x base 2. So, if we are going to plot these ordered pairs, we will have the graph of our example number 3. So, ito na po yung kanilang graph. So, we have here yung ating original, which is yung nakapula, y is equal to the logarithm of x base 2. So, ayan. And as you can observe, what happens to your graph? Ayan po. When we multiply 2 to our logarithm of x base 2. So, mapapansin nyo that nag-move siya upward. Now, let's analyze the graph by finding the domain, range, vertical asymptote, intercept, and zeros. So first, let's have the domain. Again, just by looking at the graph, we can simply identify that our domain are the set of all positive real numbers. So we will have x such that x is an element of a real number and x is greater than 0, or in interval form, that is 0, comma, positive infinity. Next, for the range, so range is the y values of our function kapag nag-substitute tayo ng ating domain or ng ating values of x. So, obviously, mapapansin nyo, positive, negative, meron namang value ng y. So, therefore, y is an element of a real number. So, that is negative infinity and positive infinity pag in-express natin into an interval form. Next, for our asymptote. So, a while ago, wala tayong horizontal asymptote. So, therefore, automatic, punta na po tayo sa ating vertical asymptote. So, upon looking or upon examining our graph, obviously, our vertical asymptote is x is equal to 0 or yung ating y-axis. And, upon checking also our graph, our x-intercept is obviously equal to 1. And with that also, we can have or we can conclude that our 0 is 1. Next, let's have this example. Let's sketch the graph of y is equal to the logarithm of x base 3 minus 1. So, determine the domain, range, vertical asymptote, and x-intercept and zeros of the graph. So, first, let's complete or construct the table of values of our y is equal to the logarithm of x base 2 minus 1. So for us to solve for the y coordinates of this function, this is just easy because we have the values of logarithm of x base 2 Ayan na, provided na siya. So, it's just easy because we are just going to minus 1. So next we proceed with solving for the y coordinates. So we have first negative 4 minus 1. So that is negative 5. Negative 3 minus 1, negative 4. Negative 2 minus 1 equal to negative 3. Negative 1 minus negative 1 equal to negative 2. 0 minus 1 equal to negative 1. 1 minus 1 equal to 0. 2 minus 1, 1. 3 minus 1 equal to 2. So, ayan po. Let's see the graph of these following functions. So, here are now the graph of our functions. So, from the sketch or from the graph of our basic function, y is equal to the logarithm of x base 3. Mapapansin mo po na yung negative 3 ay negative 1 dito implies that nagkaroon tayo ng vertical shift 1 unit downward from our graph. So, that is why some points in the basic function ay nagbago. So, specifically, halimbawa po, itong point 1, 0 natin, nag-shift siya downward. So, naging 1, negative 1. So, for this naman, we have 3, 1. So, ayan, no? Ilagay ko na lang po yung kanilang name. So, this is point 3, 1. So, nag-shift siya down to 3, 0. And this one, from 9, 2, nag-shift down. Meron tayong 9, 1. So, ito nga po ay 1, 0 and shift down 1, negative 1. So, this time, let's analyze the graph. First, let's identify its domain and range. So, again, just by looking at the graph, obviously, we can say that the domain of our graph is the element of a real number such that x is greater than 0, or in short, all positive real numbers. For our range naman, we have not positive and negative, so therefore our range is an element of real numbers. So all possible real numbers. And for our asymptote, meron lang po tayong vertical asymptote, and obviously ang ating vertical asymptote dito is our x-axis, which is x is equal to 0. So, for our intercept, we only have our x-intercept. So, kung titingnan mo po sa ating graph, 3 as our x-intercept. So, again po, aside from obtaining the x-intercept graphically, we can also solve for our x-intercept algebraically by setting our y is equal to 0. So, halimbawa, if we let y is equal to 0, so we will have our logarithm from y is equal to the logarithm of x base 3 minus 1, so that is 0, equal to the logarithm of x base 3 minus 1. So let's transpose our negative 1. So we will have 1 is equal to the logarithm of x base 3. So let's rewrite this form into an exponential form. So we will have 3 as our base, then ang ating exponent, 1 is equal to x. So obviously, equal siya sa 3. So our x-intercept is 3. For our 0 naman po, again, x-intercept also implies 0. So for this graph, our 0 is positive 3. Now, let's have our last example. Let's sketch the graph of y is equal to the logarithm of x plus 2 base 0.25. Determine the domain, range, vertical asymptote, and x-intercept, and 0 of the graph. So, for us to sketch the graph of these two functions, what we're going to do na lang po is to sketch it using GeoGebra or Desmos or any graphing softwares that you have or you know. So, ito nga po yung ating graph for the logarithm of x plus 2 base 1/4 with respect to our basic function y is equal to the logarithm of x base 1/4. So, again, if we have our original equation, which is y is equal to the logarithm of x plus 2 base 1/4, if we are going to rewrite this one into x, logarithm of x minus negative 2 base 1/4, you can see that, or you can conclude that itong ating negative 2 dito implies that our graph will have an horizontal shift 2 units to the left from our basic function. So, ayan nga po, no? So, from our basic function, yung pula, nagkaroon siya ng 2 shift or 2 units shift to the left horizontally. So, ayan, nag-skip po siya ng dalawa. So, at some point, halimbawa po, we have here the point from our basic function 4, comma, negative 1. So, nung nag-shift po siya, ito na yung naging itsura ng ating point. So, magkakaroon ka na ng point 2, comma, negative 1 horizontally. Then, let's have this one naman, yung ating 1, comma, 0. So, from 1, comma, 0, nag-shift siya papunta sa point negative 1, comma, 0. Then, we have this point. So, dito yan banda. So, this is point 0.25 or 1/4, comma, 1. Shift horizontally 2 units to the left. So, ito po ay magiging negative 1.75, comma, 1. So, when we identify points from our basic function, we can clearly see the shift that happens with our graph. Y is equal to the logarithm of x plus 2 base 1/4 with respect to its points on the graph. Now, let's analyze our graph. Let's identify the domain, range, vertical asymptote, x-intercept, and zeros or zero of our graph. For the domain, if we are going to check the graph of our y is equal to x plus 2 base 1/4, you can see that nagkaroon nga po siya ng shift. So, dahil dito, magkakaroon tayo ng changes sa ating domain. So, mangyayari, yung ating expression dati that x is greater than 0, what will happen? Kasi dahil nga po nagkaroon siya ng x plus 2 sa ating logarithm, so ibig pong sabihin nito is that magkakaroon tayo ng x plus 2 should be greater than 0. So, let's solve for x. So, our x now will be x is greater than negative 2. So, with that, we can state that our domain is an element of a real number, such element of real number where x is greater than negative 2. So, ayan naman po, no? Upon checking our graph, obviously, the graph or the possible values of our x are greater than negative 2. So, for our range, ganun pa rin po. Our range is the set of real numbers. Then, obviously naman po sa ating graph and then sa ating domain mismo, we can say that or we can conclude that our vertical asymptote is equal to negative x is equal to negative 2. Then, upon checking our graph, ang ating x-intercept for this one is negative 1, which is also ang ating 0 is negative 1. So, again, you can also solve algebraically for the x-intercept of our graph by letting our y be equal to 0. So, in summary, here are the following guidelines for graphing transformation of logarithmic function. So, for the graph of f of x is equal to a times logarithm of x minus c base b plus t, take note of the following. So, the value of b or the base, it's either greater than 1, and between 0 and 1 determines whether the graph is increasing or decreasing. So ito yung ano yung forma ng ating graph. So it's either yung kanina, yung increasing, and yung isa naman is decreasing. While for the value of A naman po, it determines naman if your graph is stretching or shrinking. And further, if A is negative, there is a reflection of the graph about the x-axis. So itong shrinking and the concept of stretching and shrinking is also the same dun sa changes or transformation na nangyari sa ating exponential function. Then ganun din kapag ka nag-negative. So based on f of x is equal to a times logarithm of x base p, vertical shift happens if d units, ayan yung d natin, implies for vertical shift, and yung c natin implies for horizontal shift. So syempre kapag ang d natin is greater than 0, so magkakaroon tayo ng d units up. Then, kapag ito naman ay less than 0, d units down. Then, again, for letter C, horizontal shift naman po siya. So, when our C is greater than 0, so magkakaroon tayo ng C units to the right. And when our C is less than 0, so you will have C units to the left.